Good morning, sir. Good morning, everyone.
Good morning. Good morning, Miss.
Good morning. Okay. So now we are going to start AC circuits, correct? So now today's class will not do from the module. I'll give you notes. So you guys make a note of it, okay? Not from the module, but make notes of it. Write on the main heading AC circuits. AC means alternating current. So write down alternating current circuits, AC circuits.
This is like the starting, no? You haven't started this pehle, no?
No, this is the new chapter, AC circuits. And in the module also, this is module 8, second chapter, if you can see, AC circuits. So first I'll teach you the concept and then we'll go to the module question answers. Okay. So in AC circuits, the first topic is called RMS current and RMS voltage. RMS in part 1 you might have studied. The full form of RMS is root mean square. The full form of RMS is root mean square. Now root mean square current and root mean square voltage. Now please look at the screen. You might have had root mean square in KTG. I hope you have studied something called RMS values. Okay, but in part 2,
VRMS.
in part 2, see this. I root mean square is maximum current upon root 2, or anything maximum by root 2 is RMS. For example, E RMS is voltage RMS is E naught by root 2, means maximum voltage by root 2. And what is the value for 1 by root 2? 1 by root 2 is 0.707. So 0.707 I naught and 0.707 E naught. And the full form of RMS is root mean square. All three mathematical words. Root mean square. Therefore, if I ask you what is RMS current, you will tell me it is I naught by root 2, where RMS is root mean square current and I naught is maximum current. So 1 minute, let me write it again. I RMS is equal to I naught by root 2. This is a formula where I RMS is And I naught is maximum current or peak current, where I naught is maximum current or peak current. So this is your first formula you need to make a note of. IRMS is I naught by root 2, where I naught is maximum current or peak current, and IRMS is root mean square current. Okay, made a note?
So basically, RMS always is like maximum
By
upon
root 2,
So
correct,
that's what you're
correct,
saying. Right?
correct, yes. So in this case, it is current, so it is maximum current upon root 2. If it was voltage, it would become voltage upon root 2. Similarly, what is ERMS?
The
E
I
naught
naught
by root
second
2.
name is what?
Voltage.
Peak. Max current or peak current?
Okay, sir. Thank you.
Now, E naught by root 2. What is ERMS? ERMS is root mean square voltage. And what is E naught? Maximum or peak voltage. Okay, make a note. These are the two formulas.
So what is the value for voltage?
Value for voltage means
RMS voltage.
E naught by root 2. Finished all of you?
Yes, sir.
Yes.
And 1 by root 2 in maths is 0.707. Therefore, you can write down as instead of I naught by root 2, 1 by root 2 is 0.707. So 0.707 I naught and 0.707 E naught. I hope you understood how. See, shall I do it? See here.
Yeah.
I is equal to I naught by root 2. I can write this as 1 by root 2 into I naught. 1 by root 2 is 1 by 1.4 something I naught. This is nothing but 0.707 I naught. Therefore, I RMS is equal to 0.707 I naught. I hope you understood. Same thing for E naught. So ERMS. Okay.
So like the one is for the maximum value as such.
This is maximum I
No.
naught. This is maximum.
Yeah.
This is RMS.
So why are we
Correct.
taking one? That
Correct.
What?
Got it, everyone?
Yes.
Sir, I asked why are we taking one?
Why one? Over here,
Yeah.
I naught by root 2 is same as 1 by root 2 into I naught, right?
Okay.
Now, see here. Next one is AC generator. Next one is AC generator. Now, please listen to me carefully. Now, whenever I take any circuit, okay, whenever I take any circuit like this, and whenever I take any circuit like this, you might have seen both the representations, okay? Now, in these kind of circuits, this means it is actually a direct current supply. It's a battery. And whenever you see this symbol, it means it is alternating current supply. Have you seen such circuits? Both the type of circuits you have seen, either you can see a battery. Now this is nothing but a cell, or you call it a battery. And this you call it as an AC supply, or you call it as an AC generator. So please, whenever you look at a circuit, you please look at the power source. If the power source is denoted like a battery, plus minus, that means that circuit is running on direct current. But if the power source is denoted like this, then it is running on alternating current. This symbol itself indicates it is alternating current. Okay? The symbol itself indicates it is alternating current. Therefore, this symbol indicates it is AC generator. Okay? And this symbol indicates it is a cell. Now, see the topic. Now, do you understand whenever this symbol comes, it is AC generator? And the formula for voltage for AC generator is E is equal to E naught sine omega t. Very, very important. E is equal to E naught sine omega t. I'm writing here, 1 minute. Where, listen to this, E is instantaneous EMF. E naught, can anyone tell me what is E naught?
Maximum or
Max-
peak voltage.
Maximum EMF or maximum voltage. And omega, can I say it is 2 pi f? Angular frequency. Everyone knows omega is 2 pi f.
Yes.
Okay. So E is instantaneous EMF, E naught is maximum EMF, and omega is angular frequency, usually is 2 pi f or 2 pi by t. Therefore, whenever you see AC generator, the formula will be of the AC generator, E is equal to E naught sine omega t. E is equal to E naught sine omega t.
So what does that means? S means जो बीच में battery में लगा हुआ है. Like in DC
That means
there is a
alternating,
battery,
like
right?
this. It is alternating. It's just a symbol.
But होता क्या होता है? Like battery होती है DC generator में, तो AC generator में क्या होता है?
AC generator will be a coil in a magnetic field. North pole, south pole, a coil is turning, and that turning generates electric field.
Okay.
Okay. AC generator, what will be there behind an AC generator? It will be a coil moving in a uniform magnetic field. And can you tell me, in EMI chapter we studied, what is the value for E naught for AC generator? Tell me, does anyone remember this value? Maximum EMF of an AC generator. Last chapter, we have done this formula. In fact, in the last class itself, we have done this formula. Maximum voltage of an AC generator is E naught is equal to NAB omega. E naught is equal to NAB omega. Yes, we have to. Okay.
Sir, can you repeat what is E?
EMF. Instantaneous EMF. So, 1 minute. So tell me, all of you, tell me, which is the first formula that we studied today? What is the first formula that we studied?
IRMS.
IRMS is equal to
I
I naught upon
I not apply to root 2.
Second formula,
ERMS is equal to E naught upon root 2.
next. What is the equation of AC generator?
E is equal to E naught sine omega
Sin
t.
omega t.
In that, what is E naught value?
NAB B omega.
Omega.
NAB omega.
And in this formula, what does omega stand for?
2 pi f.
2 pi
2
f.
pi f.
Or
Yeah.
Sir, this both the T are different, na?
what is different?
This capital T and that small
Yes.
t.
The small t is instantaneous time. Capital T is total time period. Small letter t is instantaneous time. And capital T is total time period.
Okay, sir.
Both are different, correct?
In the formula, what does that F indicates?
Frequency. Frequency. If any one of you is not understanding any term or if you want me to tell, please ask, okay? Because you have to take problems based on this.
So in that NAB omega, what is N?
Number of turns. N is number of turns. Okay. Shall we go to the next one?
Yeah.
Now, before I go to one problem, now look at the screen. Now, how do I denote a sine graph? Can I say a sine graph is a graph which starts from 0, because sine 0 is 0, and a cos graph is some graph which starts from maximum. So whenever you see a graph, and if the graph starts from 0, that is sine 0 is 0. So anytime a graph starts from 0, that means it's a sine graph. And anytime that graph starts from maximum, that is 90, that means it is a cosine graph. Therefore, looking at the basic structure of the graph, you should be able to understand whether they have drawn a sine graph or a cosine graph. We have done the same thing in oscillation also, correct? So this is a general representation of a sine graph, and this is a general representation of a cosine graph. Okay. Now, everyone switch on your cam. Switch on your cam, all of you. Now, this is a problem from your HSC textbook. I'm doing these problems because then your module becomes easier. Plus, your HSC problems also get solved indirectly. Okay. Now, this is the question. Now, try to solve with the formula that you know, and then I will also show you the answer. Try to solve how much ever you can. Start.
Sir, in this sum, the two graphs, the formula which was besides the two graphs will be applicable here.
No, in this problem, you don't have to draw any graph. You just have to find the value.
नो सर आपने अभी मतलब इसके पहले स्क्रीन दिखाया था जिसके ऊपर एक फॉर्मूला था, तो दैट फॉर्मूला विल बी अप्लाइड ना?
Yes, correct. Okay, I'll give you the beginning. See here. An alternating voltage is given by E is equal to 6 sine 314t. So everyone look at this. E is equal to 6 sine 314t. Now, if I compare it with my general equation, it becomes E is equal to E naught sine omega t. Correct? If I compare it with my general equation. Find the peak value. Now tell me, if I compare equation to equation, can I say my E naught will be 6?
Yeah.
So can I say my
Yes.
peak value
Yes.
will be 6 and I have to find the frequency means F. So can I say my omega, if I compare, it is 314 or omega is nothing but 2 pi F is equal to 314, or can I say 2 pi F is equal to, can I say 314 can be written as 100 pi? Just think about it. Because pi is 3.14. Can I say 314 is 3.14 into 100? Think about it. 314 can be written as 100 pi. If I do that, can I say my pi and pi will cancel? Or can I say my 2f is equal to 100? Therefore, my f is equal to 50 hertz.
So I didn't got this 100 wala part.
What is 314? Can I say 314 can be written as 100 into 3.14? Can I write 314 like this?
Yeah.
So can I write it as 100 into 3.14 is pi. Therefore, I substituted 314 as 100 pi. Got it?
Yes.
Now they are saying find the frequency. I found out the frequency. What is the value of frequency? Got out 50 hertz. And time period. Now tell me what is the formula for time period in terms of frequency? Can I say time period is the reciprocal of frequency? Therefore, can I say it will be 1 by 50 second? Did you get this problem, all of you? 1 by 50 is 0.02. Now check whether you're getting the same answers. What is given in the textbook? Just check.
So can you show the previous slide?
Yeah. Got it, all of you? Can we go to the next one?
Yeah.
Now, this becomes a very important page for you. And I want all of you to know this page. You don't have any derivation for NEET. You have it for your 12th. This is the summary page. Now, please look at the screen carefully. Everyone, please look at the screen carefully. I have drawn 4 circuits over here. 1, 2, 3, 4. Okay, I have drawn 4 circuits over here. Now the first one is AC generator. Tell me, we have finished this topic already.
Yeah.
We have
Yes.
done AC generator. This is the symbol of an AC generator, and this is the formula. Now, there are 3 components in electronics which are very, very important. One is a resistor. One is an inductor. We have done this in EMI chapter, self-inductance coil. In fact, this is the circuit of self-inductance. Just think, a coil connected to a power supply. And this is a capacitance. There are 3 important components in electronics. One is a resistor, one is an inductor, and one is a capacitor. Now, when I connect resistor to an AC circuit, or when I connect resistor to an AC generator, it becomes resistor circuit. When I connect an inductor L to an AC generator, it becomes inductive circuit. And when I connect a capacitor to an AC generator, it becomes capacitive circuit. Okay. What is capacitor? You still have to do it. In electrostatics, we have not done it. But what is a resistor and what is an inductor, you already know. Okay. So if I connect a resistor to a power supply AC generator, it is called resistive circuit. If I connect an inductor to a power supply, it is called inductive circuit. Then if I connect a capacitor to a power supply, it is called as capacitor. Now, look at the screen, look at the screen. Now, since AC generator is there, can I say voltage for this circuit or EMF for this circuit will be E naught sine omega t for all because AC generator is there. Therefore, E will be E naught sine omega t for all three cases. Correct? Now, only thing that changes in all three circuits is current. Just check. Only the current changes. In the first case, current remains I naught sine omega t. In the second case, current goes back by 90 degree. Therefore, I naught sine omega t minus pi by 2. And in the third case, current goes ahead by 90 degree, which is cos omega t. Always remember between sine and cos. Who is leading? Cos is leading by 90 degree. Please remember between sine and cos, who is leading? Cos is leading by how much? 90 degree. Okay. Therefore, tell me, look at the screen. Tell me in resistive circuit, who is leading? Current or voltage? Tell me.
No one.
No one is leading. Therefore, can I say both are in phase? Both are in phase because no one is leading, no one is lagging. Here, who is leading?
Correct.
Current.
Voltage is leading. Current is sine omega t minus 90. It is going back by 90. Therefore, here voltage is leading current. And over here, tell me who is leading?
Current.
Current is leading. Now listen to me carefully. Very important slide. Listen to me carefully. In a resistive circuit, there is no phase difference. Means no one is leading, no one is lagging. In inductive circuit, voltage is leading. And in capacitive circuit, current is leading. Therefore, if I want a circuit in which no one is leading and no one is lagging, I have to take a resistive circuit. If I want a circuit in which voltage is leading, I have to take an inductive circuit. And if I want to take a circuit in which current is leading, I have to take a capacitive circuit. In all three circuits, the formula for voltage E will remain the same. And current in the first case will be sine. In the second case, it will be sine minus 90. And in the third case, it will be sine plus 90. Sine plus 90 is cos. Okay. Therefore, here you can say no phase difference. Here we can say voltage is leading by 90. Here I can say current is leading by 90. Did you understand the equations? Very, very important equations. Very, very important equations. Therefore, I also want you to draw it the same way. Make 4 boxes. In the first box, only the AC generator, then resistive circuit, then inductive circuit, then capacitor circuit. Draw the diagrams of the circuits. Then I'll ask you Viva based on these questions. Okay, based on this circuit. Start.
So,
Hmm.
how will know that it is leading or not? By the symbols, capacitor and that.
See, how do we know there? How do we know in the first case? Tell me. How do we know in this case no one is leading? Tell me.
Both the sign.
Both are
And-
sine, correct?
Yeah.
Now, in this case, this is sine. This is sine minus 90. So it has gone behind sine. Therefore, can I say this is leading? Correct?
Yeah.
This is sine minus 90. Therefore, can I say this is leading by 90 degree? And in this case, this is sine and this is cos. Cos always leads sine by 90 degree. You know why? Because at 0, sine is 0, cos is maximum. Therefore, this is leading. Therefore, in this case, current is leading. In this case, voltage is leading. And in this case, there is no phase difference. Did you understand?
Yes.
So make a note, all of you. Draw this table very carefully. Done, all of you?
Yes, sir.
Now, below that you can write down, in resistive circuit, there is no phase difference. In inductive circuit, current leads voltage. You want to write like that? Voltage leads current. Actually, write down. In resistive circuit, there is no phase difference between. In resistive circuit, there is no phase difference between voltage and current. In resistive circuit, there is no phase difference between voltage and current. In inductive circuit, voltage leads current by pi by 2. E is voltage. Right.
No, sir. E is in the inductor fact that you've written in black.
Yeah, E is leading. Correct. Voltage is leading.
That is leading.
Yeah, E is leading. Yeah, voltage is leading. This one, right?
Yeah, that's leading.
Yeah, voltage is leading. So in inductive circuit, voltage is leading current by pi by 2. And in capacitive circuit, current is leading voltage by pi by 2. Now see here,
Sir, why we say pi by 2 is 90?
why we say pi by 2 is 90? Pi by 2 is in radian, 90 is in degree.
I don't know that. Radian.
Pi by 2 is in radian, 90 is in degree. Pi is 180. Pi by 2 is 90. Pi by 3 is 60. Pi by 6 is 30. Pi by 4 is 45. Tell me, does everyone know this? Degree and radian.
Yes.
Now see here, if I want to draw the graph of a resistive circuit, once please look at the screen. Now can I say in a resistive circuit, look at the equation. Look at the equation. What is E? E naught sine omega t. And what is I? I is equal to I naught sine omega t. Correct? Yes or no? Both are sine. Therefore, if I want to draw the graph of a resistive circuit, look at the screen. Can I say both voltage graph and current graph will be sine graphs, or they will start from 0? Because what does sine graph do? Sine graph starts from 0. Therefore, can I say both the graphs will start from 0 and both the graphs will reach the peak at the same point, will again come to 0 at the same point, and so on and so forth. Now see here, what is the maximum value of voltage? Check. Look at the screen. I know my maximum value for voltage is E naught. Correct? Please everyone look at the screen. Can I say maximum value is E naught? Therefore, the maximum value is E naught and it is a sine graph. Therefore, this is a sine graph for E. And same way with current. What is the formula for current? I is equal to I naught sine omega t. What is the maximum value for current? I naught. So it will go till I naught and then it will go over here. I. Is it clear? Therefore, can I say
Yes.
in resistive circuit, this is the graph of resistive circuit of voltage and current. May current.
But sir, I don't get the difference in them because there has to be no difference, no?
There has to be no
Then
difference.
why
There
is
has
the
to be a.
graph different?
What is I? E by R. Correct? What is the formula for I? E by R. Ohm's law. Therefore, I will be
Yeah.
100 by 20. For example, if resistance is 20, it will be 5. Therefore, can I say current will be less? There is no difference in terms of phase. Please look at the screen, everyone. No difference in terms of phase means both start at the same point, both reach the peak at the same point, both become 0 at the same point, both again reach the lower peak at the same point, again become 0 at the same point. This is the meaning of no phase difference. They might have different peaks, but they reach the peak at the same time. For example, when I tell you two friends are studying in phase, That means they are studying together, taking break together, enjoying together. Their marks might be different in the exam, but how they are studying is always together. So these are the marks, but they are always starting together, ending together. But at what level, that is different.
Okay, so if it is maybe conductive, so
Hmm.
in that
In
he is
inductive,
leading,
the next one
means
is saying, this one is saying,
yeah,
that time they will not be in
So
phase.
yeah, so exactly like so in this E will be leading the voltage will be running somewhere else and the current will be running somewhere
Correct, correct, correct. Even in capacitor.
Yeah, just vice versa.
Correct. Only in resistive you will get this. Did you get it, all of you? In the textbook, the solid line is voltage line and the dotted line is current line. Just check. The solid line is voltage line and the dotted line is current line. Just check. So I'll give you 1 or 2 minutes. Complete the graph for resistive circuit, E and I. If you're done, put a dot, switch on your camera. Now, this is for a resistive circuit. Now, if I look at it for a inductive circuit, please look at the screen carefully. Look at the screen. Can I say inductive circuit, the graph of voltage will be the same because E is equal to E naught sine omega t, that will not change. E is equal to E naught sine omega t. Therefore, can I say this will not change? This maximum value will be E naught. It will be the same as the previous graph itself. Why? Because the formula for E for both the circuits, that is E is equal to E naught sine omega t. Here also E is equal to E naught sine omega t. Can I say for both the cases it is same? Therefore, can I say the graph will remain the same? Now, what is the formula for current? It is sine omega t minus 90. Therefore, instead of starting from 0, I should start from minus 90. Therefore, I am starting from negative maximum. Therefore, I am starting from here and I'm getting the graph of current. In fact, it is minus cos. Do you agree? It is minus. Therefore, sine omega t should start from here. Sine omega t minus 90 will go down by 90. That means it will go to negative extreme. And from here, I will start the graph of current. Therefore, this is the graph of voltage, and this is the graph for current. Again, solid line is voltage and dotted line is current. Did you understand the graph now, all of you? Therefore, draw the graph for an inductive circuit. Start drawing the graph for an inductive circuit.
Why is the second dip small in the
Hmm?
I wala line? Why is the second dip
You can
small?
keep it bigger also. It is usually understood that the current will be lesser than voltage because current is voltage upon something like resistance, inductance, capacitance. That is why. Even in the previous case, I is lesser than E. Just check.
No. Okay.
Once you're done, please put a dot.
So
Hmm.
does that line has to be accurate, like between E
No,
and
no.
no?
It is just a rough representation. I don't need to like. Not at all accurate. It's fine. Just a rough representation. Now, for a capacitive circuit, can I say this will be the graph? Now, again, if you notice for a capacitive circuit, the voltage graph remains the same because in all three cases, voltage graph is E naught sine omega t itself. Now, in this case, what is current? Current is cos omega t. Now, you know, cos starts from maximum. Therefore, this is cos graph and this is my sine graph. That is as simple as that. Therefore, for a capacitive circuit, voltage graph will remain sine graph and current graph will become a cosine graph. So start drawing this graph for capacitive circuit. Start. Okay. Switch on your cam, all of you. Okay, listen. Tell me the first formula that we did today.
IRMS
RMS
I
root
naught
2.
upon root 2.
IRMS is I naught upon root 2. First formula. Second formula.
ERMS
ERMS E naught by root 2.
Everyone clear? Then AC generator.
E is
E is equals to E naught sine omega t.
बोलो बोलो.
This is AC generator. This is IRMS, ERMS, E. Then tell me, for a resistive circuit, what is E and what is I?
E is
E
not
is
sin
E
omega
not
t,
sin omega
and
t.
I is I not sin.
I
I
omega
not
t.
sin omega t.
Correct? Now, for an inductive circuit, L, what is E and I?
E
E
same
is
and
E
I
not
is
sin
I
omega
not
t,
sin omega
and
t.
omega t
I is
minus
I
n
not
omega
sin
t.
minus
omega
n
t
not
minus pi by
omega t minus pi by 2.
pi by 2.
Correct? For a capacitive circuit,
E is E not sin
E
omega
same
t,
and
E
I
same
is
and
I
and
I
I
sin.
is I
not
not
cos
I not
sin
omega
sin
t.
cos
omega t.
Sorry, cos.
okay? Now, in a resistive circuit, both are equal. Equal means in phase. In inductive circuit, E is leading, and in capacitive circuit, I is leading. Now, the best way to remember this is here, inductive circuit is like this, the inductor is like this. So, see here, inductor is like this means inductor is E, therefore E is leading. And in capacitive circuit, can I say capacitor is denoted like this? Okay, that means I is leading. Did you understand the code word? So in inductive circuit, E is leading, and in capacitive circuit, I is leading. Clear?
Yes, sir.
This is the summary of what we have done till now. So please go through this and tell me if you have understood. This completes 30% of your AC circuit chapter. Okay, lot of problems. We have just done the theory. You have to do problems on this. This theory wise, we have done 30%. Problems will come on these, but it's very easy. You just have to simplify comparing with general equation. I'll tell you which kind of problems will come. The problem will come like this. I will give you some time to solve it, and then I will only do it. This is actually your example 2 from your HSC textbook. Okay, why I'm showing you HSC textbook examples is, in your HSC textbook right now, the new syllabus, the questions are very similar to your NEET. They have made the level better than NCERT actually. So we'll do from both. We'll do from your module as well. So at least you'll get an idea how to solve such questions. Okay. Start and tell me what answers you're getting. Okay, let me show you. Let me start. An alternating voltage is given by E is equal to this, is connected across a pure resistor of 50 ohm. Therefore, E is equal to 140 sine 3142t. If I compare it with the general equation, that is E is equal to E naught sine omega t, can I say I will get E naught equal to 140, correct? And also I will get omega is equal to 3142. Omega I will get equal to 3142. Can I say 3142 is 1000 pi? We did
Yes.
100 pi last time. Okay. Now they are saying find the frequency of the source. Now, if I take omega is equal to 1000 pi, omega is equal to 2 pi f is equal to 1000 pi, where pi and pi will cancel, where 2f is equal to 1000, f is equal to 500 hertz. Is everyone getting this answer?
Yes.
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 And also find the RMS current through the resistor. Therefore, IRMS is I naught by root 2. Correct? Everyone clear?
Yeah.
IRMS is I naught by root 2. But can I say I naught will be equal to E naught by R, Ohm's law? Now, what is E naught value? Can I say E naught value is 140? And what is the value of R? R is 50. Everyone got it?
Yeah.
Therefore, what is I naught? It is
2.8.
Okay. Everyone, please look at the screen. I naught is 2.8. Therefore, can I say if I substitute back in the main equation, I naught is 2.8 divided by root 2, correct? I naught is 2.8 divided by root 2. Now, 2.8 divided by root 2, I'll tell you one thing. 2.8 divided by root 2 is nothing but 2.8 divided by 1.4, because root 2 is 1.4. Therefore, 1.4 ones are 1.4 twos are. Therefore, can I say my answer is almost 2 ampere, 1.98, but I will write it as 2 ampere. That is why all of you, see the answer is given on the screen. Just check what we have done the same way. All of you should know root 2 is 1.4 and root 3 is 1.7. You should know these values. Okay. Is it clear?
Yes, sir.
Yes.
Now,
Sir.
Yes, sir.
answer is 1.98, but I would like it if the answer will be 2 ampere. That is fine. Therefore, answer is actually answer over here should be 500, not 50. Just check.
$500.
It should be 500. Tell me whether you have understood.
Yes.
Yes.
Okay. Now, see here, very important concept. Listen. In a circuit, if there is a resistor, Can I say the opposition offered by a resistor is called resistance? Correct. In a circuit, if there is a resistor, have you heard of this statement? The opposition offered by a resistor is called resistance. Now tell me, in a circuit, if there is no resistance, for example, if there is an inductance, please look at the screen carefully now. Okay, just 5 minutes, 5 to 10 minutes, listen to me because very important concept. In a circuit, if there is a resistor, I can say that the opposition given by the resistor is resistance. Correct. Now, in a circuit where there is no resistance, here, can I say the opposition is offered by the inductor? Here, can I say the opposition is offered by the inductor? In this case, I cannot say resistance. Tell me why? Because there is no resistor. I can only say resistance if there is a resistor. So here, the opposition is offered by an inductor. Correct?
Inductance.
Therefore, this is called inductive reactance. Means it is called as reactance. Now, the word reactance means, listen to this, opposition offered by the resistor is called resistance. Listen to me carefully. Repeat in your mind. Opposition offered by the resistor is called resistance. Opposition offered by any other component other than resistor is called reactance. Repeat. Opposition offered by resistor is called resistance. Opposition offered by any other component other than resistance is called reactance. Therefore, opposition offered by an inductor is called inductive reactance. Similarly, can you tell me what is the opposition offered by a capacitor called?
Capacitive reactance.
Reactance.
Capacitive reactance. Okay. So can I say opposition offered by the resistor is called as resistance. Opposition offered by an inductor is called inductive reactance. Opposition offered by a capacitor is called as capacitive reactance. Therefore, resistance is denoted by R. Everyone knows resistance is denoted by R. Reactance is denoted by capital letter X. Reactance is denoted by capital letter X. Therefore, can I say inductive reactance can be denoted as XL, where L stands for inductor, and capacitive reactance is denoted by XC, where C stands for capacitance. Capacitive reactance is denoted by XC, where C stands for capacitance. Once, listen to me. Once, hold on. Can I say the unit of resistance is ohm? Unit of reactance will also be ohm because ultimately it is opposition offered to current. Okay. Till today, what was the formula for current? Voltage upon resistance, correct? All of you knew Ohm's law. Till today, the formula that you knew for current was voltage upon resistance. From today, that formula will change to voltage upon opposition. That means, listen to me carefully. What is the formula for current in the first circuit? Can I say formula for current in this circuit is E by R, correct? Now tell me, what is the formula for current in this circuit? It
E
will
by
be
XL.
E upon
E by-
XL.
correct. Over here, what will be the formula?
E upon XC.
Do you understand? From today, your formula for current should change forever. Current is not voltage upon resistance. That is only for resistive circuit. From today, if someone asks you what is the formula for current is voltage upon opposition. Now, opposition can be given by resistance also. Opposition can be given by reactance also. Therefore, opposition can be given by resistance also, and opposition can be given by reactance also. Now, inductive reactance is denoted by XL. Capacitive reactance is denoted by XC. In other words, reactance is denoted by capital X. And the unit of reactance is same as resistance, which is ohm. Okay. So just make a note of this page, what I have drawn, so that you understand. Start.
So what should be the heading?
So my
Opposition. Why L? Because inductor is denoted by L. Inductor is
Okay.
denoted by L, self-inductance, correct? Side heading opposition. Okay, now 30-second more, finish it quick. Now, now the formula for inductive, now look at the screen. Now the formula for inductive reactance and capacitive reactance is on your screen. Look at the screen. You know reactance is denoted by the letter X, correct? And you know there are two types of reactance. One is inductive reactance, which is denoted as XL, and one is capacitive reactance, which is denoted as XC, correct? The formula is XL is equal to omega L, and you know omega is 2 pi f. Therefore, you just have to remember XL is equal to omega L and XC is equal to 1 by omega C. Start. Make a note of this whole page. Two more formulae. Inductive reactance XL is equal to omega L and capacitive reactance XC is equal to 1 by omega C. Okay, now see here. You know that in this circuit there is resistance and in this circuit there is reactance. Switch on your cam, all of you. Now what happens if a circuit has both resistance and inductance? Then will you call this circuit resistive or will you call this circuit reactive? My question to you. What if a circuit has both resistance as well as inductance? Will you call this circuit resistive or will you call this circuit reactive? Because this will be resistance R, this will be reactance XL. Therefore, can I say in this circuit I have both resistance and reactance? Can I say in this circuit I have both resistance and reactance? Therefore, in a circuit which has both resistance and reactance, that circuit is impedance. What is impedance? Either I can have resistive circuit or I can have reactive circuit. But what happens if both come together? Means I have a resistor also, I have inductor also, I have capacitor also. In such case, can I say opposition is offered by resistance also, plus opposition is offered by reactance also? In such a case, the circuit is called impedance circuit and the notation is Z. Therefore, if anyone tells you that the circuit has impedance, that means the circuit has resistance plus inductance or capacitance or either or. Okay, that is why it is called as impedance circuit. And the formula for impedance circuit is, I will show it to you on the screen. Formula for impedance circuit is don't write this right now. The formula for impedance circuit is this: Z is equal to square root of R square plus XL minus XC the whole square. Now, can I say in this formula, I have all three terms R, XL and XC. Therefore, if a circuit has a combination of resistance and reactance, that circuit is said to be an impedance circuit, and impedance is denoted by the letter Z. Now, can anyone tell me what should be the unit of impedance? Can anyone tell me what should be the unit of impedance?
Ohm.
Answer will be ohm itself, because even impedance is opposition. Can I say even impedance is opposition offered to the circuit? Therefore, write down side heading impedance, write down the formula, Z is equal to square root of R square plus XL minus XC the whole square. And the unit of impedance is ohm. And the unit of impedance is ohm.
So can you show the diagram?
So this is applicable when all the three resistance and resistor is known now.
Not all three. Resistance or inductor, I'll tell you the diagrams. Now, okay, first copy the diagram, then I'll tell you the cases. Okay, first copy the formula, then I'll tell you the cases.
Done.
So Z is equal to square root of R square plus XL minus XC the whole square, and the unit is ohm. Finished?
Done, sir.
Now all of you look at this screen. Tell me, this circuit, now the question for you is, tell me, this circuit is resistive circuit, reactive circuit or impedance circuit? Is it R, X or Z?
Resistive. Resistive.
It is a resistance circuit, correct? And what is the formula for current in this circuit?
E upon R.
is equal to E upon R.
Correct? Okay, now. This is R, X or
Inductive
Z?
reactance.
Excel.
Excel.
This is your reactive circuit, correct? This is your reactive circuit. And in reactive, it is inductive reactive circuit. And what is the formula for current in this circuit?
E upon
Excel.
X.
Upon Excel.
I upon X. E upon Excel.
Now, now tell me whether this is R, X, or Z.
XC.
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 X,
XC.
Z. And what is the formula?
E upon XC.
E upon
E upon
XC.
XC.
Okay. Now, tell me, in this, it is resistance, reactance, or impedance?
Impedance.
Reactance.
Impedance.
It is not impedance. I'll tell you why.
Reactance.
It is only reactance. I'll tell you why. Because it is inductor and capacitor. Both are reactance. Therefore, the combined reactance will be XL minus XC or XC minus XL, whichever is greater. It is not an impedance circuit because impedance comes when resistance plus reactance is equal to impedance. But in this circuit, can I say it is only reactance? Now tell me the formula for current in this circuit.
E upon XL
E
minus
upon
XC.
XL XC.
Therefore, can I say how many resistive circuits are possible? Can I say one resistive circuit is possible? Just check. How many reactance circuit are possible? 3. 1, 2, 3. Correct, everyone? How many reactance circuit are possible? 3. Now, next page, I will show you all cases of impedance. Made a note of this? Everyone clear with this? Everyone should know which is resistive circuit, which is a reactive circuit. Okay, now. Now tell me whether I will have reactance, resistance, or impedance.
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 Because resistance is there and XL is also there. Therefore, tell me what is the formula for impedance in this circuit? Can I say in this circuit, the formula is R square plus XL square? Because XC is not there, I don't need to write it, just check. It is actually, what is the formula for impedance? Square root of R square
R
plus
square.
XL minus XC the whole square. But in this case, there is no C. Akansha, which impedance statement? Impedance will come if there is resistance plus reactance. Impedance will come if there is resistance plus reactance. Okay, Akansha.
Yes, sir.
Therefore, what is the formula for current in this circuit? I is equal to E by Z. Current is equal to voltage upon opposition, correct? Current is equal to voltage upon opposition. Therefore, I is equal to E by Z. Written? Now tell me. Is it R, X, or Z circuit?
Z.
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 Z. Tell me the formula for Z in this case.
R
Z will be
Square
R
plus
square
XC
plus
square.
X square.
And what is I equal to?
E upon Z.
E by Z.
E by Z.
Now, can you tell me one more scenario for impedance circuit?
It'll be
All
XL
three in one.
Together.
XC.
Correct? It will be R, XL, XC. Then can I say Z will be the actual formula that you have written? Square root of R square plus XL minus XC the whole square. And over here also I will be equal to E by Z. Therefore, can I say these are the three cases possible for impedance circuit? 1, 2, 3. Just check. Remember the unit of R, X, and Z. All three is ohm. The unit of R, X, and Z. The unit of all three will be ohm.
So can you flip to the previous page? So then why is the last wala not impedance?
Impedance will come only if there is resistance plus reactance, correct? But in the last one,
Okay, so
I have both reactance.
okay, so resistance has to be there. Uske baad any
Exactly.
of the reactants from the way.
Yes.
Okay.
There is no impedance without resistance. Think about this statement. There is no impedance without resistance because impedance is resistance plus reactance. Resistance has to be there. But over here, both are reactants. So I can take XL minus XC or XC minus XL, whichever is greater. So if I ask you how many resistive circuits are possible, you will tell me 1. How many reactive circuits are possible? 3, which are on your screen. And how many impedance circuits are possible? Also 3, which are on your screen. Easy?
Yes, sir.
Yes, sir.
Now we have done many things today and many formulae today. Okay. So we'll do a recap. Okay. We'll do a recap. Everyone listen. First, what did we do today? IRMS and ERMS. Okay. So first we did IRMS is equal to I naught by root 2. And we did ERMS is equal to E naught by root 2. Everyone clear with this? Clear, all of you? Okay. Then we did AC generator. In AC generator, I got E is equal to E naught sine omega t, where the value for E naught is NAB omega. This value is from EMI chapter only. The value for E naught is NAB omega. Clear? Then we did a resistive circuit, that is resistance connected to a supply. There we got the formula for E and I. E will remain as it is, E naught sine omega t, even for an inductive circuit and for a capacitive circuit. The value for E will not change. What is the value for E? E naught sine omega t. Here also it is E naught sine omega t. Over here, the value of I will be I naught sine omega t. Therefore, both are in phase. Here it will be I naught sine omega t minus 90. Therefore, can I say current is lagging or voltage is leading? Here it is I naught cos omega t. Therefore, current is leading. This much is clear. Then we got the
Yes.
formula for inductive reactance, which is omega L. Then we got the formula for capacitive reactance, which is 1 by omega C. And then we got the formula for impedance, which is equal to square root of R square plus XL minus XC, the whole square. Tell me, this much is clear, all of you? And how many resistance circuits are possible? 1. How many reactance circuits are possible? 3.
3.
How many impedance circuits are possible? 3.
3.
Unit of resistance, ohm. Unit of
Ohm.
reactance, ohm. Unit of... So if you go to Olympiads, right? See, R also stands for opposition. X also stands for opposition. Z also stands for opposition. Therefore, in your Olympiads, science Olympiads, they will tell you what you know, which is the odd letter out. So they will give you R, they will give you X, they will give you Z, and they'll give you W. Which is the odd letter out? Answer is W. You know why? Because all these are opposition. Similarly, in tell me, can you complete the sequence? A, B, AB, dash. Can you complete? Looking at the first 3, can you complete the last one? What is this question mark? Anyone? Switch on your camera, all of you.
Minus AB.
Minus AV, BA. Okay, BA.
BA.
No, answer will be O, because these are the 4 blood groups. As NEET students, you should know how to fill in the sequence. Okay, these are all Olympiad questions. A, B, AB, and O are the 4 blood groups, not BA. Okay, so I hope now you understood how to fill in the sequence. Okay, so we have done inductive reactance, we have done capacitive reactance, we have done impedance. Got it? We will do one problem more and then we will stop for today. And we'll be very happy to know we have completed 50% of the chapter already. Not that easy, but I think the way which we have done or which we have answered, I think you have understood what is resistance, what is inductive reactance, and what is impedance. We'll do one problem. Next class, we will solve problems on all these formulae. Check. I have written so many formula on the screen today that we have done first screen and the second screen. Based on these two formulae pages, we will solve problems in the next class. But today, we will solve one more problem and then we'll stop for today. Let me go to the problem. See here. Example 13.6. We just have to find the impedance. Okay, no time lag. Time lag I have not yet done, so we'll not do that. This is the question. Everyone, please look at the screen. A coil. Switch on your cam. Switch on your cam. Quick. A coil of 0.01 H inductance. That means, can I say self-inductance L is 0.01 Henry. Okay. And 1 ohm resistance R equal to 1 ohm is connected to a 200 volt. That means maximum voltage is 200. Actually, it's not 200. It's RMS has to be 200. But doesn't matter in this case. Okay. And 50 hertz. F is equal to 50 hertz. This will not be E0. This will just be E. Find the impedance of the circuit. Now, please look at the screen. So there is an inductor and a resistor connected to some supply. Okay. Now tell me, in this case, what is the formula for impedance? Can anyone tell me what is the formula for impedance in this case?
Impedance is
Z
equals
equals
to
R
to
square
root of R square plus XL square.
R square plus XL square, because XC is not there. And what is the formula for XL?
omega L.
Omega L, or omega L can be written as
Omega L.
2 pi FL
2 pi F.
because F is given. Now look at the screen. Look at the screen. Can I say you have understood this formula for impedance? Z is equal to square root of R square plus XL square. Now, can I say R square plus XL can be written as omega L? Omega L can be written as 2 pi FL the whole square. Now, R is given as 1, 2 as it is, pi is 3.142, F is given as 50, and inductance was given as 0.01. Now, that square you have to do. Don't solve it. Don't solve it. When you solve it, you will get some answer. Square root of almost 10. Square root of 9 is 3. Therefore, square root of 10 will be 3 point something. Calculation is not important because numbers will definitely change. Did you understand which formula to use and what you have to substitute? Okay. Therefore,
sir.
in this case, Z would be square root of R square plus XL square, not XC, because C is not there. And XL is equal to omega L equal to 2 pi FL. Only that you have to substitute. Got it, all of you?
Yes, sir.
Okay, perfect. So with that, we will stop for today. We'll stop at 9, not 9:30. We'll stop at 9. And in the next class, I want you to be ready with your module. Okay, today we did not do anything from the module.
The module
Please keep your module number 8. In that, the first chapter was EMI. Now we'll start with AC circuits. That is the second chapter. This Sunday, it will only be EMI. I told you last class also. This Sunday, you will only have EMI. Next Sunday, you will have only AC circuits. No EM waves, because EM waves is already done. Okay, in the past. Okay, so this Sunday, EMI. Next Sunday, AC circuits. Okay, so this Sunday's EMI is already done. Keep revising that module. Okay, so thank you everyone. I'll see you next week. Okay, bye bye. Not next week, this
Bye,
week only,
sir.
one more class.
Bye.
Thank you.
sir.
Bye bye.
Bye, sir.
Bye bye. Bye bye.
No, sir.
Bye bye.